So we move on to our next speaker, Puneet Kala. Greet him with applause as always, please.
So good afternoon, everyone. Before we begin, just a disclaimer, whatever I share today is for general discussion and informational purposes only. These are my own views and not my employers or the hosts. So let's imagine a scenario. There is a blind person who is walking on a busy street. They are about to reach a pedestrian crossing and the signal is red. There is a challenge here. Let's imagine another scenario. There is a busy street again and there is the same blind person walking. But this time they have an AI-powered app which tells them when the signal is red. They wait there, and when the signal turns green, the AI-powered app tells them that the signal is green, and they start crossing the road. This is the promise which AI brings with it. Good afternoon, everyone. My name is Puneet Kala. I have come all the way from Berlin to talk about accessibility. I'm a senior software engineer at Zalando for Android accessibility. Today, we are going to talk about intersection of AI and accessibility, the challenges with accessibility, and the promise AI brings with it to solve them. Let's begin. So going through the agenda today, we are going to go through how AI is already helping us out there in digital accessibility. Then we will talk about how assistive technologies have evolved and about the AI's role in that evolution. Then we will understand the power of Google's media pipe and how it can help us build accessible apps. I have prepared a quick demo to help you, to show you this. And finally, we will talk about how to make AI itself accessible. Let's start with AI in digital accessibility. So what is digital accessibility about? Let's imagine three scenarios. In all of them, there is a person who is traveling in a metro, a crowded metro. The person is on a call with another person, and that person needs some details from this person. So they have to open their Photos app, zoom a photo, pan it a little, and read out the details on the call. In scenario one, the person has a baby in one hand. In scenario two, their hand is fractured. And in the scenario three, they have only one arm. Now, in all these scenarios, they effectively have only one hand available with them, although the duration of this availability is different. The situation one here is called scenario one here is called situational disability. The scenario two here is called temporary disability, and the scenario three here is called permanent disability. If there would have been an app which allows them to zoom using plus minus button, or if they are able to pan using the arrow keys, that application would not have made would have made the experience accessible for everyone. That is what digital accessibility is all about. It's making sure that the tools which we have, like software, like apps, website, documents, anything, are usable or accessible to everyone, irrespective of the condition. But why does it matter to us? So I'll give you three reasons which corporates generally listen to. The first one is user base, the second one is money, and the third is legal compliance. So according to Eurostat 2023, 26.8% people in age 16 and above in EU have some kind of disability. If we talk about the global numbers, 1.3 billion people worldwide have some kind of disability. That comes to around 16% of the world population. Now, an important question to ask is, do 27% users of your app are people with disabilities? If the answer is yes, then we are good. If the answer is no, you are missing out on a potential $1.5 trillion market. People with disabilities in EU have $1.5 trillion disposable income. That's a guesstimate. It's $8 trillion worldwide. So if you are a global app, you are missing out on potential $8 trillion market. Apart from that, we have European Accessibility Act. So as of 28 June 2025, all the EU companies or the companies which are providing their services in EU needs to be accessible as per European Accessibility Act. So they basically require the apps and websites to be WCAG 2.x AA compliant, not 2.1 or 2.2, but 2.x, and whatever the latest version of the second WCAG is. So now let's talk about how AI is already helping us out there. So we might have, many of you might have heard about screen readers like TalkBack, like VoiceOver. Now these can describe complex content better now. For example, if you have a toolbar which has a back button which is unlabeled, a TalkBack will be able to announce it as back button because it can now understand the content. Apart from that, it can also describe, it can also summarize screens for you. So there is a recent feature which has come up with Gemini in TalkBack where you can just summarize what's on screen. Apart from that, we have computer vision and image recognition. So if you have you heard about apps called Google's Lookout or Microsoft Seeing? Now, what these apps do, they are able to describe the text which is in front of you. They can describe the objects. They can describe people or even currencies in front of you. They can read food labels on the cans, on the food boxes to help you make a healthy choice. And Google's Lookout can help you navigate rooms by identifying things like chairs, doors, and many other things. Apart from that, there is something which we use daily, so which is voice control and speech to text. So we might have heard about Google Gemini, Apple Siri, Amazon Alexa. So these are just example of voice control and speech to text. I mean, there is Google Assistant, but it's now slowly being replaced by Google Gemini. So someone who has difficulty typing, or if they prefer speaking, being able to talk to your phone and having the phone react to what you are saying feels very, very empowering. Apart from that, we are seeing more and more AI-driven personalization. For example, there is Google's Gboard or Microsoft's Swift key. Now, these both keyboards learn how we communicate, what are the common words which we use, or what are the common phrases which we use, and then they suggest the next words accordingly. Apart from that, apps like Duolingo have personalized learning sessions for you, which can help you develop your weak skills or enhance your stronger skills even better. So these are just a few examples of how accessibility is already helping us out there. Now, let's understand the evolution of these technologies in a little detail. Starting with evolution of screen readers. So in the earlier days, screen readers like TalkBack or VoiceOver were just basic text-to-speech converters. What they were doing was they were going through app's accessibility tree. They were finding out what the text is or what the content description is. which is being said, and they were just announcing it. Now, a challenge came when the UI started to become more complex. For example, there were swipeable carousels, like we can see them in the Play Store app, or there were bottom sheets which were coming up. Then there were sliders where you can just, for example, there could be price sliders, and people were building a lot of custom elements. Often, when the custom elements were being built, engineers often forgot to make them accessible as well. Apart from that, we had dynamic content where there were constantly updating product lists or product images. And we had things like festive offers, we had things like sales. So the home pages of the apps or websites were becoming richer and richer. Then the next challenge was that there was a need of context awareness. So for example, if we take Play Store, they have a listing page where they list apps. And whenever you click any app, you land on a details page. Now, the image which you see on a listing page has a different context. The image which you see on the details page has a different context. The listing page image the image on the listing page is there because so that you can land on the details page. So it requires a different announcement, and the images which are on the details page, they show you what's actually inside the app, or how, for example, how does the app work. So they need different announcements. So what this meant was that the old ways were not enough, and new and smart solutions were needed. And that's how AI is solving the problem. So as I already told, for example, TalkBack recently came up with Gemini. And now what happens is whenever you ask Gemini to summarize the screen or describe what's on the screen, it also understands what kind of page it is, and it describes you accordingly. Apart from that, there are screen readers which are adjusting to your speaking speed, or which are adjusting to your pitch so that you can understand the content better. And apart from that, there is an ongoing research which is called dynamic restructuring. Now, what dynamic restructuring is, let's say you have a web page and it's not accessible. So what this would do is, this would change the structure of the website without changing the look, and it would basically make the website accessible. So it's going to be a lot less stressing for engineers and a lot more helpful for people with disabilities. Then we have AI-generated summaries. There are article summaries which can be which we can get very easily now with the help of LLMs. So these are a few things which AI is already helping with in terms of screen readers. Then we have the next thing, which is navigation. So what are the most common tools which are used by blind people, for example? So they use white canes, they use guide dogs, they use electronic travel aids. So what electronic travel aids are, they are devices which use ultrasonic signals to find objects in front of the device, and then they notify user either through sound or through vibrations. Now, all these tools are still being used, but each tool has their own challenge. For example, guide dogs are very expensive, and they take a lot of time to train. Or white cane cannot help you understand if there is a red signal in front of you or a green signal. Apart from that, when it came to about accessing knowledge, for example, just reading books, there was either a need of large print books, or the people were using magnifiers. So we might have seen our grandparents using magnifier to read newspapers. Then there were Braille books available in Braille, but they themselves required users to know Braille. So if there was a person who didn't know Braille, then it would be useless. for them. Apart from that, there was an OCR device, which was very frequently used. And what you had to do was you just had to scroll it through the line on your book, and it would just keep announcing the word which you are scrolling through. So what was happening was, for day-to-day tasks, there was a lot of human dependency on human assistance to get a full picture of what is around you and to navigate the world around you. So now, what promise AI brings? So first of all, smartphones became intelligent eyes. Now we have apps which can describe real-time, like objects in front of us in real time. So I would highly recommend you to you that when you go back, please use Google Lookout and try to navigate from one room to another just by following the instructions which it gives. So what's happening because of this is, for example, let's say if someone is going on a street and they want to enter a cafeteria, these apps can tell them that there is a door in front of them. They have to open the door to get inside the cafeteria. So this is basically reducing reliance on others and giving people more independence to navigate their world on their own and as per their wish. So when people go to restaurants and they do not have braille menus, blind people, for example, can still order something for them on their own, which was a challenge before AI came in. So let's talk about evolution of personalization now. So imagine there is a maths teacher. Their students are not doing that well. And the head of the department has asked them to improve the grades of the students. Now, what maths teacher will have to do is to understand where the students are, in which subjects students are weak. For example, are the students weak in geometry? Are they weak in algebra or what? So they'll have to go through the scores of students and try to identify weakness and strengths of everyone. After this, there are two possible options which the teacher has. Either they can create a personalized learning plan for every student so that they can improve on their weaknesses, but this is going to require a lot of time and a lot of effort. So this is a very, very intensive job for them. Or they can basically pick up what the most of the class is weak in, and then they just teach that subject so that the overall grades of the class improve. So even though the second option solves their problem, but if the possibility of first option would have helped everyone learn better, and there could be scenarios where people can improve onto certain topics, but then there would be next set of topics which they'll have to think about. So there is a lot of requirement of tweaking here. So maths, if it's a normal maths, then it's okay. But if we talk about something like very complex physics theory, now this would actually make things even more difficult because there is a need of specialized educators to solve something like this. So we have so the challenge was that nothing was scalable in such scenarios, and there was very difficult to give a truly personalized experience. And this is how AI is basically helping us solve. So AI has made personalization scalable and real time. Now there are apps where you can solve maths questions. The apps determine your learning ability, what you're weak in, what you're strong in, and then they can have a learning experience based on that. Again, then there is adoption. So it also basically is kind of adapting the content as per what you are doing. So predictive text is another such example where the content adapts to users' need. Now, let's say if there is a 6-year-old student and they want to, go to their father and they ask a question. I threw a ball in the air. Why did it came back down? Well, the father knows gravity, but obviously explaining gravity to a 6-year-old is a difficult task. It's not an easy task. So how AI is helping you, helping there is that they can basically simplify the complex theories in an understandable language. So for example, you can just prompt ChatGPT, how do I explain gravity to a 6-year-old kid? And you will get a response to explain that 6-year-old kid. This means that AI is also adapting to the learning experience. Now, how this is helping is, this has, according to studies, this has reduced the cognitive load on students by 41%. This means AI is not making you dumber, it's actually making you smarter. Now, let's talk about power of Google's MediaPipe. So what is MediaPipe? MediaPipe is an open source project which comes up under Google AI Edge. So it's a suite of libraries for ML and AI. It has 4 things: tasks, which are cross-platform APIs and libraries for deploying solutions. There are models, which are pre-trained, ready-to-run models for use with each solutions. Then there are model maker, which can help customize models for solution with our own data. And then there is Studio, which helps us visualize, evaluate, and benchmark our solutions in our browser. So let's see a quick demo for the same. So 2 things happened here. The first thing was gesture recognition. So when I displayed close fist to my camera, it basically scrolled the content on its own. When I displayed it a thumbs up, it basically went back. And when I displayed it the open palm, it actually went to the home screen. Now, for people people with mobility disabilities, it's very empowering if they are able to use their phones without needing to touch them. Or even there are users who basically prefer not to touch the screens and use their phones with gestures. So technologies like Google's MediaPipe actually help build accessible apps. The second thing is screen summary generation. So although you might have seen that the demo was clipped a little because I didn't want you to wait for the summary because it may take time depending on the device. But the interesting thing is whatever we saw here was happening, everything here was happening on device. So there was no server-side processing involved. The AI was actually using the device capabilities to do all these tasks. So how did we reach here? So as you can see in the image, our implementation uses MediaPipe's task text, task gen AI, and task vision. So this allows us to process gestures locally on our phone, eliminating the need to send the sensitive video data to the cloud. So what this means is we are immediately getting the feedback for actions like scrolling or navigating, which is absolutely critical for safety and independence in many cases. So the gesture recognition proof of concept basically showcases the speed and responsiveness here. Then with the screen summarization feature, we use MediaPipe's Gen AI capabilities, which were again processed on device. So this is highly beneficial for privacy but it's a bit slow. It could be a bit slower. So in this particular case, we use Gamma 3.task model, which was a very heavy model, and I made this demo on Fairphone phone, which does not have any capabilities and does not have a lot of processing power itself. So let's understand the precise sequence of events when a gesture is performed or a summary is requested. So when you perform a gesture, our camera gesture service springs into action. It's running as a foreground service, constantly analyzing frames from our camera using MediaPipe's gesture recognizer. So the moment gesture like closed fist is detected, the service broadcasts an intent. Now, this intent is picked up by our global accessibility service. So this service is crucial as it has the permission to interact with the Android system on your behalf. So for a closed fist action, we saw the scroll forward action. For thumb up, we saw the back action. And for the open palm, we saw the home action. So now for the feature, summary feature, when we tap the floating button, the global accessibility service collects all the visible text from our screen. Then this text is sent to the LLM processing service, which is also running on the device, which uses the Gamma 3.task LLM model, again powered by MediaPipe to generate a concise summary. While this provides great privacy by keeping data on device, the processing time again can vary based on the phone's hardware. So once the summary is ready, it is sent back to the global accessibility service, which then displays it in an overlay on our screen. The end-to-end device processing ensures privacy and a responsive but sometimes slower experience. So if someone here is interested in exploring this further or building on top of that, I would be happy to share the source code with you. Now, let's jump to the final topic of today's talk, which is making AI itself accessible. So we have spent a lot of time discussing how AI can revolutionize accessibility for people with disability. But another crucial dimension is making AI itself accessible. This starts with very foundation of AI, which is our training data. So AI models are going to be as good as and as fair as the data they are trained on. So if data sets have biases, the models themselves are going to be unfair or they are going to be discriminatory. So we need to have a proactive approach and mitigate this bias so that we ensure that AI serves everyone equally. Then we need to focus on modern interpretability, which is also called explainable AI. So many powerful AI today are black boxes, which make decisions in a way which are not transparent to even the people who have created them. So for accessibility, this is a significant challenge because users and developers need to understand why an AI system makes a particular decision, especially in a high-stakes situation. Explainable AI aims to create more transparent models that can explain their rationale, strengths, and weaknesses. So this helps build trust amongst users and allows for appropriate human oversight and intervention, ensuring that the AI is a tool that can be understood and managed by all, regardless of their abilities. And finally, and critically, is the UI UX of AI tools themselves. So, for example, if we are using ChatGPT, it needs to be accessible itself for people to be able to use it. So, coming to conclusion, so the core message which I have shared today so the first is the immense potential of AI to enhance accessibility and inclusivity for individuals with disabilities. Second, the AI technologies that are already assisting individuals with disabilities. Third, the exciting promise of Google's Media 5 for future accessibility applications. And the fourth is the importance of strategies for making AI itself more accessible. So what can we do next as engineers? I have 3 points for you. First of all, please explore Google's MediaPipe. Think about how these tools can help you make more smarter and more helpful apps for all users right on their phones. Then design for all users. It's important to work closely with people who have different needs, including those with disabilities, and make sure our designs and the data which we use for AI are fair and include everyone. This would help us avoid problems like biases or discrimination. And finally, use AI for good. Find ways in your own project where AI can help you remove barriers. Think about how AI can make apps easier to use and better for all people. Together, we can create a more inclusive and accessible world. So thank you very much, DevFest Vienna, for this opportunity, and thank you all for listening. We are open for questions now.